Welcome, everyone. I see that we scared a few people away with the topic of DevOps. I know it's not a typical thing that blockchain developers think of when they think of, building blockchain applications, but that's why we're here to talk about this. So a little introduction into the topic. Just want to start off with like a scary situation. So everyone will deal with this. Everyone will encounter a situation at one point or another. Production is down, right? That's not a good situation. You don't know what to do. You, instead of wanting to call over, say you scale your business and you have production team, operations team, devs, you don't want to reach out to all of them. You don't want to bother them on a Saturday. What if I told you you just had a solution where you can just log on your computer, you know exactly what's wrong, you just click a button and it solves itself. That's what DevOps does for application development. Makes it much more seamless, it makes it much more reliable, way more just easier to fix things. That's what we all want. So a bit about myself. My name is Alec Kleyer. I'm a senior DevOps engineer at Ripple. I've been in the industry for about over 5 years now, working on building out scalable platforms, automating deployment patterns, just working with developers and making developers' lives easier.
Hi guys, my name is Moses Marquez. I've been working here at Ripple for quite some time now. I'm a senior DevOps engineer. I work just alongside with Alec. My main focus and what I work on is usually just security, monitoring, and distributed systems. And so that's, and I've been in the industry for about 6 years or so. All
right. So that's what we're going to talk about today, but it's more of like a story, right? We're going to introduce the main characters. We're going to do a little bit of character development. And then we're going to tie it all in the end, and you're going to be wowed. So Moses, take it away.
Yeah,
what is DevOps? Tell me.
Yeah, so DevOps, now with a raise of hands, I'm not sure if anybody knows or what resembles DevOps to you, and what would you say as far as like what it means to you? What is DevOps? Just maybe one or two hands.
Sorry.
Go ahead.
Deploying software.
Okay, good answer.
Anyone else? Yeah. Yes.
Go ahead.
Application lifecycle management, yeah.
That's a great one, yeah. Awesome, all great answers. That's perfect, these are great answers. Yeah, so, next slide. Yeah, so what is, so basically what DevOps is how we see it, or how I see fit, is a culture. It's basically sharing a responsibility between development and operations, and showing ways that we're building tools in a more unified, customer focused. And so it's a mindset, it's a way to help the whole ecosystem of building great software and deploying production-based software out to our customers, right? Yeah, so that's what culture means to me, but go ahead.
For me, it's all about automation. As I mentioned before, my whole career I've just been helping developers make their lives easier. They always have just a ton of manual tasks that they run where they have to type in a few lines of code and run a bunch of commands, go to this guy, go to that guy, ask a bunch of people for help. But with implementing DevOps in your deployment patterns, deployment pipelines, you're able to integrate a bunch of different stuff together with just one click of a button. So there's already a bunch of automation tools out there. It's so easy to automate a lot of stuff. It's not a scary topic, I promise you. There is a lot we're going to go into, but there's already a bunch of tools that automate it for you, and that's why I love DevOps. So now we're going to go a little bit deeper. This is where the character development comes in. I'll kick it off with the first topic. First and foremost, continuous integration. This is where everything starts. In a quick development scheme, whenever you're just starting off your small business, your startup, you have an idea, you just want to get it into the cloud, you want to start showing it to people, you want to start demoing it. Your typical deployment pattern would be you have just one branch, you have your master branch in GitHub, right? You commit into GitHub and you build it using whatever tool you want and you just put it into some remote registry, ideally. And say, for example, you deploy to production, your production environment, and there's a bug. How do you go about fixing that? You go back to your code, you quickly change something, you put it into master branch, you deploy it, and there's a bug again, and you're not testing for everything. This is where a CI tool is extremely useful. You have tools such as Jenkins, Circle CI, to name a few, GitLab, GitHub Actions now has its own thing, where you commit something into a branch, and as soon as you commit it into a branch, you have this pipeline that you created for yourself. You define all of your test cases to encompass all of your edge cases, all your use cases. And it does everything for you every single time you commit your code. It's extremely useful, extremely fast. It makes your code development extremely reliable. And for this diagram, I wanted to stress that there's not only a master branch. I know you guys don't just use a master branch. But when you develop based off the Git flow, you work off feature branches. And everyone knows feature branches. You work on your feature. You push into either develop or master. Everyone knows that strategy. But you can integrate specific testing based off specific branches. If you have like a test branch, a bug fix branch, a feature branch. Say you're just adding a new feature to your code. You commit it into your feature branch, and you sync that into your CI tool. That CI tool, GitHub Actions or Jenkins, for example, it automatically picks up the latest code, compiles it, whatever's in that feature branch, and it tests for specific things that you want to test for. You could have added something to the pipeline to test for this new feature. And the CI tool will be able to return a status based on all of your tests that are passed, failed. You'll know everything, and everything's all in one integrated area. You have everything in front of you. And you can either, based on these results, merge into master, and again, build it based on another set of test scenarios. Or you can just set up automatic merging. You can do all of this stuff, just connect it. You commit it to feature branch, it syncs, it tests, and it merges into master branch. Again, automatic. Syncs into CI tool, pushes into the artifact registry, and that's it. All you have to do is just commit it to a feature branch. Everything just happens for you. Then is the continuous deployment or delivery. Sometimes it's used synonymously. I'm just going to talk about continuous deployment. So once you have your artifact in your artifact registry, what happens, right? A lot of the time, some developers, when you're quickly developing, you create an image, you put it into the ECS, ECR, you put it into Google Cloud Registry, and then you just spin up a new compute instance with the new image, and you test that way. But with a CD tool, you're able to put this CD tool, either use a SaaS tool to integrate with your cloud environment, or you can even put a CD tool right inside of your cluster if you're using a Kubernetes cluster or ECS or anything like that. And this CD tool will be able to pick up any new changes. So you committed this code, and it went through all that stuff with the CI tool, all that continuous integration, and now it's in the artifact registry. And automatically, the CD tool will pick up this artifact. It'll notice it's a change, and it'll know based on a tagging scheme, if you tagged it as a feature, as a new version, as a new release. It'll know based off that. Again, this is stuff that you can define with the CD tool. It'll know whether to deploy to dev, staging, or prod. And again, automatically, depending on the pipelines you set up, it deploys into dev. And if it passes a certain amount of test cases that you had set up for it, it'll know to automatically promote it through the staging environment and then into production. So all this stuff, again, the beauty of the CD tool and the CI tool is just to automate all this flow away from you. You don't have to worry about, oh, I got to commit this, and then I don't know which region to spin up this new test. Because you don't want to bring down your production compute instance, right? You want to spin up a new one and test it, see if it works. Again, all this stuff is just handled with the CD tool. The one that we use, so again, with GitHub Actions, you're able to do the CI part and do the CD part. We don't advocate for that. There's specific CD tools, like for example, at Ripple, we use Argo CD. And Argo CD uses another term, which I'm not going to go too deep into, which is GitOps. And with GitOps, it's wonderful. You're able to, with just a few YAML files, you're able to define the state of your application that you want in your production environment, or your staging environment, or your dev environment. With a YAML file, you're able to just define what image, with which configurations, going into which cluster, into which namespace, which Helm chart you want to deploy into there. Everything is defined with just a few YAML files. So big fan of Argo. There's a lot of other stuff, that you can get into if you deploy with Ansible or Helm, or if you just want to spin up some compute instances. So definitely something to look into. Last thing that I'm going to talk about is infrastructure. So just curious, with a show of hands, who builds applications in the cloud?
Oh, plenty of you guys.
Yeah,
That's awesome.
okay. And who builds locally? Okay, so most
Sweet.
people build in the cloud. I actually figured that most people build locally. But so people who build in the cloud, who uses AWS? Okay, and do you guys use CloudFormation or Terraform? Terraform, okay.
Sweet.
So it's exactly what I imagined. About like 1% of you guys are using infrastructure automation, and it's extremely, extremely powerful. So in an instance of, say, how annoying is it, for example, if you have a running infrastructure, if you have a running application and the infrastructure you built out by hand, you love it, it's working, everything's great, and then all of a sudden one of your developers goes in and just like, I don't know, messes with like the resources of your database, and then like you have a bunch of like errors when communicating with the database, or somebody just takes away like a PubSub resource or just something, and maybe you were just doing it to like test something to see if something will work better or fix a problem, but then you forgot what you did, or changing it back to what it was before. Like you don't exactly know how to go about it because it's not that easy. Well, with infrastructure automation, with a tool like Terraform is what we use at Ripple. Again, same thing as the GitOps. You just have some YAML files that set the state that you want it to run as. You have a good state. You define a good state of exactly what VPC you want to create, what multiple VPCs you want to create, what kind of cluster you want running in which environment. You can create clusters. You can create an entire cloud environment. You can even automate the creation of local infrastructure with Terraform. Again, all of this is set up with YAML files. And the beauty of that is like you could just, if someone does something in production where it like breaks it because of an infrastructure change, you can just go back, run Terraform, apply, one command, and everything's back to normal. It's fantastic. It's saved us a bunch of times. Another use case, if you wanted to scale your environment, it's very difficult to go into, well, it's not difficult to click some buttons, but for example, if you want to just recreate everything that you did, but like more and better, and you don't know exactly like to what extent you want to do, you don't want to just be clicking buttons all the time. With infrastructure, with Terraform, again, you just go into the YAML files, you dictate what you want your remote state to look like, and just run infrastructure plan. There's two commands. There's the plan and there's the apply. The plan shows you what's going to be created in the cloud environment based on what you change in the YAML files. So it does a diff against your local state and the remote state, which is stored in a bucket, and it's kept away from the code. It's not stored in the code. It's stored in a remote bucket. So ideally, it shouldn't be touched. You should never touch the remote state bucket because it should always reflect what's remote. Mm-hmm. Another situation, just for example, if you wanted to, if you have, for a lot of you here today, you might be doing a demo, and if you have a working production environment, but you want to run a demo, you don't want to run it in your dev environment, you don't want to, because you might be doing stuff in there that just doesn't work right with your production environment, and you definitely don't want to be doing this in your production environment. So you could just quickly spin up another environment with way less things, just remove a few things from your YAML files. You can just create a demo environment with the click of a button again. It's super easy and you're up and running with the demo. And you know that environment will work because you've tested it before. So now Moses is going to go into a few other things that have to do with the overall encompassing of what to do after deploying an application.
Awesome. Thank you, Alec, for that amazing presentation. That's awesome. Thank you so much. That's perfect. So I'm going to go into more into monitoring. And now the reason why we want to talk a little bit more about monitoring, and especially in DevOps, is that we do get lost sometimes in developing our applications. And at times when we develop our applications, we don't set up monitoring in our deployment process, and partly of that it's because like I said, that we're always looking to develop better, great applications. But with doing so, we want to find ways to actually debug or troubleshoot our issues or some root causes that we have, right? And so part of monitoring that helps us, that helps also you guys as developers to ensure that you guys are building amazing applications, right? And so I want to go into saying is that we have found a proper way to monitor application and infrastructure. So with both application and infrastructure, does have a few, I would say, bells and whistles for each individually. And I am assuming most of you guys are developers, right? And so I am going to touch a little bit on infrastructure. And so partly what we do here at Ripple is we use a tool called Prometheus. I'm sure you guys, some of you have heard of it before. And Prometheus is just a simple, basically a time series service that can collect data, scrape data from your applications, or I would say more your infrastructure in this case, in this scenario. And so with doing so, once it's scraping those metrics and those are enabled, then we use another tool called Grafana. And Grafana uses that data from Prometheus that's able to extract that metric, collect time series database in order to visualize basically pain points in your infrastructure where things are getting bottlenecked or things are not working the way that it should be, right? And so those are kind of the two things that we look at when we use a lot of for our infrastructure, but not to go into too much into that, but I'm gonna go into now more of the application side of things, right? And so the next thing I do wanna let you guys know is this is kind of something, this is like a perfect example what application monitoring looks like. Okay, so if you see here on your top left corner here, that's the Elastic APM agent. Which is basically that's your application performance monitoring agent that is able to do tracing on Node.js applications, Java applications, Python applications, and and everything. Just as a disclaimer here, most of these applications, all of these applications that you see here in services are all open source. So they're pretty much free to use. They're not locked in or anything like that. And usually how I would like to state this too, you can always set up like an instance of all these services at deployment where you don't have to have a large cluster into doing so, right? You can do that, but it could be very much costly by putting this in the infrastructure and putting this up on the cloud, right? And so if you want to cater to one application, this is an amazing diagram how it can show you. Now I'm going to walk through these steps here. And so, so the APM, like I said, it's a very easy agent that basically can trace pretty much any programming language that is available right now. Now, the second one, as you can see there on the bottom left, is an Open Telemetry Collector. Now, Open Telemetry Collector is a great tool as well to use in the event where you want a more catered application performance monitoring, and that is set up as like a small instance of a server, and as you can see that little Golang, looks like he's looking down as a detective. That's Jagger, and Jagger is an SDK that you can write to the Open Telemetry Collector that basically essentially sends all that information to, as you can see, the APM agent or the Open Telemetry Collector to that server, and once it goes to that server, then it basically writes everything to the Elasticsearch. And the Elasticsearch is basically that all-encompassing storage where now once all of this stored metrics and even logs as well from Kibana and Grafana are great. These are great data visualization tools. Now the thing about Kibana, and just as a fun fact, Grafana is a fork of Kibana. So, but at the time, when Grafana was trying to make their own visualization tools at the time, they weren't supported by Kibana, so they went and ventured off, right? Just like XRPL and Bitcoin, and this is basically a fork of, and so they made it, now it's like a standard as of today for Kibana is more of a log explorer, and versus Grafana, you can create some like amazing customized dashboards on this front. So this is what it will look like on a diagram scenario. So this, now I do want to emphasize this, it's very easy to set up. It's usually just looking all through on an open source. You go just to the repo, it's just simple scripts that you can just write, or different containers basically along with your application that you can feed. And this allows you to actually figure out where are pain points or root causes within your applications that are not working correctly, right? So that's exactly what it is. Yeah. So performance of load testing. All right, so performance of load testing is something that is extremely vital in most applications. Now, one of the reasons why is because whether we want to break the whether it breaks the application or makes the application. Okay, and so what I mean by that is that, and that's what you want. You want to be able to see to what degree that your application can test. Can test to the whether it's scaling, which I'm going to go into right now, and different levels of performance and load testing, right? And so let me go ahead and So here's the next slide. All right, so as here on your top one is load testing, right? So load testing is basically your all-encompassing, just figuring out resources where if the load testing is working, if the load testing, so it's like imitating a high load on your system and ensuring that there's no latency issues, error timeouts, making sure that there's not much memory leaks, or figuring out what load testing is. And second is endurance testing. Now, endurance testing is basically a more prolonged test on seeing how, and by the way, most of these functions can be used with K6 or Locus. I'm not sure if you guys heard of these. K6 and Locus are great open source tools as well that you can use, that small scripts that whether you want to either use any of these here, it has those functionalities where you can have that. And then going into volume testing. Now, volume testing is more in terms of high data load, right? Or high, making sure that, or having a number of users in order to actually figure out if volume testing is something that it's working the way that it should be with simultaneous users on your applications, right? Yeah, so, and then the next part I want to talk about is scalability testing, right? So scalability testing is testing out the application, setting up for elasticity, and making sure that it's in a state where your application's ready to scale. It already has the infrastructure it has, where you're using load balancers, you're using specific mediums in order to ready to go to scale your application. But in doing so, this allows you to figure out, within let's say in a scenario where 1,000 users is able to actually hit all of your 3 nodes, right? So that's where you start seeing that there's so many bottlenecks, and then that's where you want to start thinking of ways of okay, these are the amount of users I'm going to start looking into scaling. I want to be able to scale up to 2,000 users instead, right? And this is let's say within a minute, or you can get really modular with it, right? And so this is where you want to look at to figure out how you can scale your user base, right? So next thing is spike testing. Think of load like it's load testing, but with all together. It's just pretty much a figuring out a way that making sure that, let's say in the event of a DDoS attack, or let's say it's just all encompassing all just once, and just figuring out what kind of reports you can get back from making sure that through a spike test it could handle, let's say, 100,000 requests per second or something like that. That's the most amount that you can within a spike test, right? The next thing is stress tests. So stress tests, now stress testing is more understanding the more upper limits and beyond the expected maximum or expected, making sure that it's opposed to bottlenecks, right? So you want to just figure out how it works in that realm, right? So yeah, so like I said, just keep in mind this is to find all the pain points and exploit them in order to start thinking different ways that we can program our applications more effectively. Not efficiently, because if you're doing it efficiently, you're cutting corners, right? So more effectively, I'm sure you guys are aware with asynchronous CPU, thread modeling, where you can program in that sense. And so by allowing yourself to think how to program it in a such fashion that it could handle a lot of these tests, or where you guys have to look at to start programming it, just better applications, right? Yeah. Security. All right, so security is this is the last point I want to discuss, and something I'm sure everybody cares about is security, right? And so we're on the blockchain, and this is a very important topic for me because I come from a big security background. Now, obviously, we've coined the term DevSecOps. How original, right? I want to emphasize that security should be placed at every DevOps process, every single pipeline that we try to emphasize ourselves at Ripple. And so there's many ways about going about doing this. Now, partly one of these is I would want to go into is code scanning. There's code scanning. There's already available. There's a bunch of resources online on open source tools that we not only that we use. There's that can actually figure out anti-patterns, container scanning, making sure that you're not using CVC important, basically codes out there that's been exploited. And so we want to look at it in a way that not only to close those vulnerabilities, but not allowing hackers to actually giving them access to, any of our stuff or non-privileged access. So that goes from infrastructure to applications as well, right? So that's pretty much, and when you deploy code, you want to, how I'd always see it, this is something that's very key to me, you want to be using something like SSL or TLS for the most part, wherever you can. And I'm saying that just because you're encrypting your information, and that's just something that we do at Ripple. So, and then when you monitor, when you do monitor for security, you look for, there's already monitoring tools as well for security, where you can start looking for suspicious activity. We don't allow, or you don't expect, let's say, a country from Romania or a country from Brazil or something that flags certain, I would say certain countries that or they're coming in with an Ubuntu laptop or something that it's just like most of our users are all using Apple or Windows. There's ways that you can look at clients and making sure that you guys are monitoring this correctly. So yep. So yeah. So just in the next topic. Oh,
how are we on time?
How are we on time?
3 minutes over.
3 minutes over. All right. Let's quickly breeze. I know. This is the good part. Okay. Let's quickly go through this.
So go ahead, Alec.
No, this is you.
Oh, this is me.
Yeah,
okay.
go ahead.
All right. So applying to blockchain applications. Now you guys build blockchain applications that interact with the XRPL, right? And so a bit more and specific and some interesting stuff that we've encountered building on the Google platform. And so one of it is our KYC and PPI confidential storage. Now, KYC is knowing your customer's information, and with doing so, we've actually figured out a way where there should be different type of, for one, we should have a way to have a confidential data perimeter, a data governance perimeter, and a data ingestion project here. Now, as of now, what we have like a cloud, for instance, there's in Google Cloud, they have cloud storage, we have pub sub for streaming data, and data identification. Now, data identification is like, they use a Google, I believe it's Google service recovery, or is it service recovery?
It's a long name.
Yeah, it's a long name actually. Yeah, Google data loss prevention, right? So through de-identification, they use instead of using, through this de-identification, they use cryptographic tokens in order to send to BigQuery. And then when sending it to BigQuery, it's completely encrypted. All that information is not even Google can't even see it. It's very confidential. And so from there, this data governance perimeter, use Cloud HSM for, like, let's say for security, so like let's say for private keys, data loss prevention, like I was just talking about, data catalog, and then re-identification in order to go back and actually be able to read from certain services that your app requires, right? So this is a great, so then go ahead.
Yeah, so quickly.
Yeah.
This is a simple setup if your application is interacting with an Exchange or the Ripple API servers, right? So this is a situation which a lot of you might encounter, and this is a simple setup of how you can have it in the cloud. So for people who are developing locally and are afraid to put their stuff in the cloud, as Moses discussed, the KYC and PPI, storage, Google and Amazon, I'm sure too, and Azure and all those cloud providers, they have all these tools to help you store all this confidential information. But if you're interacting with an exchange and say the exchange is signing the transactions for you, or you're retrieving the KYC of your customers from the exchange, and you don't necessarily need to keep the confidential information on your platform, this is a simple setup you can have. You can have your API and UI services running behind cloud load balancers to distribute the load from your end users, as you see here. And in terms of restricting access, you want to I want to stress this. It's called least privilege access. This is something that's always stressed when you create an application or a service in the cloud. Least privilege access is something that everyone should stress. It's essentially setting your restrictions to everything, just making sure no one has access to anything, and start from there. And with this chart, all you need to give access to for your egress and ingress rules are to the Ripple API servers if you're interacting with externally with the public API and with the crypto exchange. And last slide, a lot of people might be wondering if you're able to host a private Ripple D cluster of your own in the cloud, and yes, it is possible.
Yes. So with the private chain using GCP, now what you want to go about doing this, if you guys want to go ahead and set up your own Ripple D servers and using your own applications, what you want to go out, now these two blue slides, I mean these two blue boxes there, you want to separate these virtual into two different private clouds, and I do suggest setting up VPC peering where you have a redundant on that right side, yeah. So on that right side, you want to set up a cluster where they have their own zones, regional zones, and within communicating with your application, as you can see here, this would be your application. And so that would be just a simple setup that you guys can be completely secured. And VPC peering usually have IPsec already enabled. So you don't have to worry about not having your information encrypted to your Ripple D servers within a private chain.
All right. And again, that's it. So as Elon said, you gotta care about DevOps.
Yeah.
The point of this presentation was just to show you that DevOps is really simple to integrate because there's a bunch of open source tools out there that does all of this stuff, all the stuff that we talked about. It does it all for you. You just need to add some integrations into your pipelines. So yeah, and next slide is just Q&A.
Yeah.
So if anyone has any questions, thank you for listening to us preach about DevOps. Hope you enjoyed the content.